Hello, this is Dr. Harrington, Lecture 6, page 6. So let's go ahead and get started. Again, we're doing some more applications. We see that the unit price P of a new model television is a function of the average number of units sold weekly, X. The financial department of the manufacturer has observed that this relationship appears to be linear. So again, we're going to be using a model of a line, y equals mx plus b, for this particular model. If an average of 1,000 television sets sell weekly, when the price of the unit is $500, and the demand increases by 200 units per week when the price is lowered by $10. We want to find the demand function that models this relationship. Okay, so the thing you want to note is that demand is going to be of the form P is going to be some slope times X, remember, and X is, of course, the number of units, is the demand, plus B. So that's the number of units that we have. So first of all, we want to find M. So the slope is going to be the change in P over the change in X. Alright, so that's going to be, let's see how we can figure that one out. If it increases by $10, then, let's see, if the demand increases 200 units when the price is lowered by $10. So if the price is lowered by $10, then we see that the demand increases by 200. So we actually get negative 1 over 20. So again, I got all that from this one line right there. So now I have the formula P is equal to negative 1 over 20 times X plus B. So I still need to figure out, well, what is this B? So 2, I need to find B. And typically a specific data point is all you need. So let's see, if I come over here, if an average of 1,000 televisions sells weekly when the price is $500. So right there, that tells me that when X, the number of televisions we have, is 1,000, then the price P is 500. So now let's just plug it into the formula. So I'm going to have 500 is equal to negative 1 over 20 times 1,000. So I'm just putting it into the formula right there. So right into this formula, or that formula, plus B. So let's see what that says. I'm going to have 1,000 divided by 20, so I'm going to have 500 is equal to negative 50 plus B. So that just means that B is equal to 550. So the equation that I have for demand is P is equal to negative 1 over 20 times X plus 550. Okay. For the next guy, find the revenue. Now this is what you have to know. This is going to appear the rest of the semester. We see that revenue is, of course, the number of items that you have, number of items, times the cost per item. Cost per item. And again, you can just rewrite that as just X times P. X times the price. So our revenue function, R of X, is equal to X times negative 1 over 20X plus 500. So I'm just, 550. Which is equal to negative 1 over 20 x squared plus 550x. Just distribute that x through. All right, we can still have some more questions on this we can ask. So the question is, if I want to bring in the most amount of money, if I want to bring in the most revenue, how many televisions should be sold to maximize the revenue? How many should I try to sell. Okay, so here's what I have. Really, I have that revenue, I'll just rewrite the revenue function, is equal to negative 1 over 20x squared plus 550x. Now what you're going to notice is that as the parabola, this is actually going downwards. So we see the parabola is pointing down. And we're going to have a maximum there, which is our vertex. Okay? So we want to maximize at the vertex. So it's maximized at the vertex. So we have x is equal to negative b over 2a. This is my a, and that's my b. So I have negative 550 divided by 2 times negative 1 over 20, which is 550 divided by 1 over 10, which is just equal to 5,500. So if I want to bring in the most amount of money, the most revenue, then I need to sell 5,500 televisions. So we need 5,500 televisions. Okay. Now, suppose I can actually figure out how much it costs to make these things. And the question is, I want to maximize my profit, for example, with the cost and all that. So here I have the fixed cost of productions for televisions are $6,500 per month, and the variable costs are given by this formula. I want to find the cost function, find the profit function, which then gives us the total profit for the monthly sales of TVs, and then how many televisions should I sold per month to maximize my profit. Okay, so what I'm going to do first is figure out what my actual cost is going to be. So my cost, C of x, that's going to be equal to my variable costs plus my fixed cost. And let's see if I can figure that out just by looking at the word problem I have here. So that's going to be equal to 0.01x squared plus 70x. So that's my variable costs given in the word problem, and then I'm going to have some fixed costs of 6,500. Now, my profit from this, and this is something you should also know, profit is equal to our revenue minus cost. Whoops. Oh, I think I had that backwards. Revenue minus cost. So that's going to be equal to our revenue. Let me see, go back to this here. That's our revenue. So our revenue is going to be negative 1 over 20x squared plus 550x. And then minus the costs. Now remember, the cost is going to have we have a minus sign here, so you have to make sure that you distribute that through. So I have 0.01x squared plus 70x plus 6,500. Okay. Now, let's clean this up a little bit. Now 1 over 20 is 0.5. So I think I'll just put everything in terms of decimals to make my life a little bit easier. Why not? Now profit, now this is kind of confusing because we have demand is P, profit is P, everything is P. So just to keep everything straight, I put a little bar underneath my P just to remember this is the profit. The lowercase p is the price, right, from the demand. So we use P's for everything in this class, so it sometimes gets confusing. This is now profit. So my profit is going to be negative 0.05x squared plus 550x. This is going to be minus 0.01x squared minus 70x minus 6,500. Okay. So my profit, let's just clean this up a little bit. That and that. This is going to be minus 0.06x squared, and then I'm going to combine all my x's. Let's see, that should be 480. Yep. Okay, so that's going to be plus. Yep. Okay. Plus 480x, and then left over minus 6,500. Now remember, I want to maximize my profit. This number here is negative in front, so just like in the last problem, we see that the parabola is going to be going down, and if I want to maximize it, it's going to be that little vertex there. Okay, so the vertex formula, I'm going to have x is equal to negative b over 2a. So I have negative b, which is negative 480, divided by 2 times negative 0.06, okay, which is equal to 480 divided by 0.12. And again, I hate decimals, so let's just multiply everything through by 100 on the top and the bottom to remove that. So I get 48,000 divided by 12, and that should make it a lot easier. It's just 4,000. Now, what should the price be? So again, we need to sell 4,000 to maximize profit. We need to sell 5,500 to maximize revenue. So remember, these are different values. So the price for this, what should I set the price at to maximize my actual profit? The price, this is lowercase p, lowercase, 4,000. Remember, what was my price? This was, this is my price. So I'm going to have negative 1 over 20 times 4,000 plus 500. Oh, 5, what was it? Let me make sure I look at it. 550, sorry. So it's actually 550. Forgot that. 550, which is equal to negative 200. Let's multiply that, plus 550. And that should come out to be $350. Whoops. $50. So what that means is that we should price the TVs at $350. This should maximize our profit, and we should aim for 4,000, selling 4,000 units. 4,000 TVs. Cool.